Just something in more detail about the contact fungicides or the protectants. Obviously, they remain on the surface. They're usually effective against a wide range of fungi, and in general, they do not promote the development of resistant populations in the pathogens. They target multiple metabolic sites, as I said, many steps, but they need to be reapplied quite frequently because they're only on the surface of the plant, and they can wash off with irrigation or rain, or may not remain very effective for very long. And you also, in most cases, need a complete coverage to get the necessary control. Systemic fungicides, on the other hand, they could be eradicative or curative, and they are absorbed into the plant tissues. And most of them are what we call locally systemic. In other words, if the droplet lands on the leaf, it will move to a certain extent on the surface. Or they could be translaminar. This is the lamina or the leaf blade. So if it lands on the top, it will move through to the lower surface, or the other way around. Many of them are not truly systemic. In other words, if I spray a leaf at the bottom of the plant, it will move up into all plant parts. They're not that good, but some of them will be better than others. What have we? They kill or inhibit the organisms without harming the plant. Mode of action is specific, and this is an important point. Resistance is more likely to occur with repeated use of these compounds. They do not wash off the surface. They are xylem mobile, in other words, mostly move upwards in the xylem after they've been absorbed. And thinking just about stem rust, and I think Dave and I have talked about this, when you spray wheat for stem rust, you only cover the canopy, the top part. You will not get the downward movement, and you will not get good control. So if you want to spray established infections of stem rust, you've got to make sure you apply the product to the stems. Seed treatment also very important, and in most countries you cannot buy commercial seed that's untreated. All of it will be pre-treated by the companies that sell them. And interesting, when we go back into history and to see what the Romans did many years ago, they also treated seeds, especially against the bunts or the smuts, and they used ethanol and ammonium, and then later on mercury became popular, because we know mercury is very toxic to mammals, so that was then withdrawn. But for ethanol they used wine. They soaked the seeds in wine, and for ammonium they used urine, just from their livestock. And whether it worked, I don't know. They also used seawater to get the salt, because they had to do something to control. So there are some very interesting stories in history about early seed treatments. And there are many advantages. It's relatively easy to apply, relatively inexpensive. It's effective because all your plants are treated if you treat all the seeds. And it is, I think, supplementary to many other methods. And the more modern systemic seed treatments will also control rust to a certain extent. The application could be as a dry powder treatment or a wet treatment. And for the wet treatments, you usually have an adhesive and combined with the active ingredient. And it could be pelleting or a slurry, which is a very thick suspension that's sprayed onto the seeds, or just soaking. And there are a few examples of older seed treatment fungicides, as well as some of the more new ones like fluconazole, which is quite popular these days in certain areas. Now, Gordon talked about gene stewardship. Fungicide stewardship is equally important. So when we use the contact compounds with multiple modes of action, it's unlikely that the organisms will become resistant or insensitive to those compounds. The systemic ones, resistance is more likely to develop. I mentioned the Fungicide Resistance Action Committee, and you can go to the FRAC table, download that for free. You can see this was updated in February of this year, so they do it quite regularly. And they start with the mode of action, and in this case, nucleic acid synthesis, the target site, the group name, the chemical group, the common name of the compound, and then comments on resistance. High risk, medium risk, resistance not known, this is a bactericide, etc. So you can go through the entire table. It's quite a long table. And then they give it a FRAC code. So when you have a 4 and you buy a different product, which also a 4, you know they both have the same modes of action. And you will probably want to avoid that and spray something with a different mode of action to prevent the development of resistance.
But there's no regulation of that. No.
What you can spray.
Yeah, so if I'm a farmer and I spray 4, there's nothing preventing me from... Yeah.
It's your decision, or then the person advising you. Yeah. And usually the person advising you to spray is someone who gets commission on how much product he sells. So it's a tough environment. So you've got to be informed, I think, as a farmer, to make the right decisions. And the basic, we don't have to go into the details, but the basic way or method of avoiding resistance is to use mixtures and alternations of different active ingredients. I don't know too much about the development of resistance in the rusts specifically. I recall something about Asian soybean rust being reported recently as showing up resistant to certain compounds, but I couldn't find the paper on the internet this morning. So I don't know where I read it, whether it was in an APS bulletin or...
In wheat rust, I can't recall the reference, which says that rust will not develop resistance because of some mechanism in the rust. In something like respiration, something. I haven't... Yeah. That's why.
I think rusts are considered as medium risk to develop resistance, but if you think of the chemical groups that are active against rust, the one is the QOIs, the strobilurins. A lot of resistance is known in other pathogens towards that particular group. Yeah. So I think one has to be really careful if you repeatedly spray that particular compounds. Then the DMIs or the triazoles, it's also very common. It's also considered medium risk. And then there's a third group, the SBHIs. I think I'm not exactly sure, but resistance has also been reported within that group. And there are many other things to consider. If I have a resistant spore, that spore must now survive this season and to the next to be able to develop a resistant population. So it's not only the inherent ability to become resistant, it's also some epidemiological factors that will allow it to survive and then continue for the next season. If you want to read more about cereal diseases and resistance, this is a UK publication from 2013. They spray a lot of fungicides in Europe and the UK because of the environment. And there's some valuable information in this particular publication. You can see they have septoria, powdery mildew, then something on the rusts, tan spot, etc. So you can read this publication. Unfortunately, I did not put this on the in the package, but you can download it just by Googling fungicide resistance UK document or something, and you will find it.